All right, Algebra 2. Today we're learning new properties of logarithms. It's called expanding logarithms and condensing logarithms. We're going to be going over today 3 properties, and I think there's a total of 8 we're going to be learning. The first one is the product property. It looks like this. The second one is a quotient property. It looks like this. The third one is a power property, and it looks like this. But in order to explain it, I think it's much better to show it. You will get a list of these properties for logarithms at some point, but for now, I recommend creating your own list. So with that said, I'm going to go ahead and just get into the examples. That way y'all can see them if you need this help again. Okay, so expand each logarithm. So we know now, before I get into this, we know what logarithms are, and you don't have to write this part down. We know that essentially if we had, let's say, I don't have my thing plugged in, 1 second. We know that if we have this right here, if I had log, and again, don't write this down. This is just me making stuff up, 10 to the 100. This is going to evaluate to 2. If you were to type this in, the log base 10 to 100, and type this in, your answer would be 2. This comes out to a number. And so what happens if you have crazy, it comes out to not just a number, but an exponent. But what happens when you have crazy stuff like this? Well, there are cool things we can do to actually help us solve these problems. So watch what this says. This says expand each property, each logarithmic property. You see this base right here? I count 1, 2, 3 things being multiplied together. We have a 5, an x, and a y being multiplied together. Watch this. Look what it can do. Plus. How does this expand? We're going to end up expanding it using plus signs. Now, for those who are like, I don't understand, why would we possibly be using plus signs when it comes to multiplying? Well, y'all, this is dealing with exponents. This is dealing with exponents. Do y'all remember this? If I had, and don't write this part down, x to the 4th times x to the 5th. When we're multiplying them together, what's the rule? The rule is we add them together. So we end up with x to the 9. So that's where that plus comes from, right here. When we're multiplying exponents, or bases together, and they have exponents, you add them like this. So that's why we're going to end up adding it. So number 1, this is how it would work. That's what you would do. You just basically do it like that. Check out number 2. I'm going to expand this one. This one has log base 5, but this is 6 divided by 7. So watch what this looks like. Log base 5, 6, are you ready? Minus, and then I'm going to basically make sure there's a way to do this when they get more complicated. But if I were you, I would go ahead and get in the habit of every time there's a minus, make sure you get a parentheses going. The base is 5, and then 7. And why do I have it like this in case it's like this? You'll see later. But it's in the interest of distributing that negative sign. So now we have this one right here. This is the power rule. This one was an example of the quotient rule. This one's an example of the quotient rule. The one above was a product. I didn't write it down. The one above was the product rule. And then number 3 is going to be the power rule. So check this out. The power rule looks like this. The power rule is this has log base 2 of x raised to the power of 3. Watch what I'm going to do with this 3. I'm going to rewrite it like this. I can pull that out in front, and I can now, bam, have this here. And why can I do this? Because remember, this log 2x, log base 2 of x, is an exponent. And what's the rule when we have an exponent on top of an exponent? Multiplication. So I can take this exponent and put it out in the front and then just multiply. It's kind of tricky and weird, but you get used to it as you do these problems. I'm going to show you this one. This is my first step. Are you ready? I would have log base 3 of 4 plus log base 3 of x squared. And a lot of you will be like, Mr., I don't even understand why we're doing this. Like, these you just have to do. After a while, they start making sense. But it's brand new language for you. It's brand new thoughts, everything else. Now, I'm going to go through and I'm going to do something else right here. You see this exponent I have for this 2? Watch what I'm going to do now. I'm basically applying multiple rules now. I'm going to take that 2 out and put it in the front. And these rules do have a point. The more you learn these rules, the easier solving these equations become. And they kind of become kind of fun. So that's how you solve that right there. That is what expanding means. So I'm going to go to the next page of notes. And I'm going to do some fun ones right here. This one looks crazy, and it kind of is. But I'm going to do the first step like this. I'm going to say log of 7 base 2 plus, I'm going to do this. I'm going to put this log base 7x. But do you see that exponent? I'm going to skip a step and I'm going to throw it right there. And then I have this plus log base 7 y, but you see that exponent 8? I'm going to go ahead and plug it in right there. And then I have this stuff. Now this is where the minus with the parentheses comes into play. So now this is the dividing bar. A dividing bar gets the minus sign right there. And if I'm not doing a very good job on explaining this, it's because you just have to do it. This is one of those types of weird maths. Now, you ready for this weirdness? You see how the bottom of this has 3 times z to the 4th? Well, we have this minus sign representing this divisor bar. We're going to be doing the same thing. Watch how I do this. I'm going to have log base 7 of z, and then it has an exponent, so I'm going to put it here. And then I'm going to leave this like that. And now you can leave this answer like this, or you can distribute your minus sign. But this is 100% the correct way to do it. So that's what I wanted to show you. I wanted to at least show you all of those there. I'm going to go ahead and rewrite number 7 and number 8 so you can see what we're trying to do. And this is what number 7 would be rewritten as. Log of 9 x to the 1/2 over y squared. So do you see how I turned that into that? I'm going to rewrite 8 for you as well. I have log. Mister, there's no base. This is another rule of the game. If there's no base, the default is 10. The default is 10. If you do not see a base, the default is 10. And I'll talk about that today. You'll get used to that as we do these more. I'm going to rewrite this product right here. This will be x to the 2/3. And then this would be y to the 5th. Now, why does that help us when I rewrite this radical house in terms of exponents? Because then I can basically do this rule. I'm going to expand it. So watch my solution on this one. I'll have 1/2 log base 9x minus, I know it's a lot, 2 log 9 base y. Where did I get that 2 from? It's the exponent. Where's the exponent? Yada, yada. So I'm going to blow through this in class pretty quickly as well because I want y'all to have time to work on this. You need time to work on this more than you need me to do more of these examples. All right. See you in class.